Alright, now this problem definitely looks like a division problem. The other one kind of didn't because it said to the negative first, and it looked like multiplication, but you recognize definitely the division symbol right here. What we're going to do is we're going to write it as a long division problem, at least at first. We may not continue it as a long division problem. We'll talk about that in a second. So we're going to write everything down and make it look like it's a long division problem. Alright, there we go. If you remember, box top. Okay, the top one goes in the box. Okay, it's this divide. It's the first one divided by the second one, so the first one goes in the box. That's what I call it. Now you could do this as a long division problem, but we learned another way. We learned synthetic division. But before we do synthetic division, we have to do something with this. We can't have this 2r minus 3. We only want this to be an r. So what we're going to do is we're going to divide everything, everything, top and bottom, by 2 so that it's r minus something. So divide that by 2 and that by 2. Same thing with all of these. And let's see what we get. So we're going to get r minus 3 halves. And then inside of here is just going to be r cubed plus 5 halves r squared minus that 2 over 2 goes once, so that's just an r minus 15 over 2. Now this is what we're going to do as our division problem. Now it looks even worse than what we started with, but using synthetic division, this really works out really nice. So if you remember synthetic division, you put a little backwards division symbol here, and we're going to take this sign right here. It's going to be inside of here is x minus whatever the number is, or r in this case, r minus 3 halves. So what goes in here? Not a negative 3 halves, just the 3 halves, because our little formula says r minus this number goes right here. Now what we're going to do for the rest of this, we're going to put the coefficients. So let's figure out what the coefficients are. The coefficient. Now also make sure it goes down stepwise. Watch, this is going to be this is r cubed, this is r squared, this is r to the first, and this is the constant. Make sure there's no gaps in between there. So since we're good, we can put a 1 right here. Then our next one is a 5 halves. Next one is a minus 1. Make sure you take care to notice what the signs are, and then it's going to be minus 15 over 2. And we'll put a little line. Leave yourself some room because we're going to write some stuff inside of this. Now the very first thing we do is to take this 1 and drop it below the line. Whatever that number is. It doesn't have to be a 1, but whatever that number is, we drop it under the line. Now we take this thing and multiply it. Let's do it. It's easy. 3 halves times 1 is 3 halves. So you put the 3 halves right here. Take these and add them up. 5 halves plus 3 halves is 8 halves. 8 halves is the same thing as 4. Might as well just simplify it right off the bat, make it a little easier on ourselves. Now we just start the routine all over again. We take this thing on the outside and multiply it by 4. Well, if you're not sure about that, jot it over here off to the side. 3 halves times 4, that goes once, that goes twice, that's a 6. So that's a 6 right there. I'm going to multiply these two together, I put it underneath the next number, and you get a 6. Add these columns up. Remember, these columns will always be added up. Negative 1 plus 6 is positive 5. Now let's start the routine again. 3 halves times 5. Again, if you can't do it in your head, write it down. 3 halves times 5 over 1, that's 15 halves. It's positive 15 halves. Now look, we thought it was going to be kind of ugly because of the fractions, but really the fractions weren't that difficult at all. Look what happens. Negative 15 halves plus 15 halves is just a 0. Now, what in the world does this mean as far as my answer is concerned? Remember, this one right here is always your constant. I'm sorry, I lied. I didn't really lie, I just messed up. This one right here is your remainder. This one right here is your constant. This is the x term, or in this case we're using the letter r. That's going to be the r term, and then you're just going to go up. So he just kind of builds up. Remainder, constant, the r to the first, and this is going to be the r to the second, or r squared. So when we write it all together, watch, it's 1r squared, 4r, 5 is the constant, no remainder. So let's write it nice and neat. R squared plus 4r plus 5, and then there's no remainder, don't have to worry about that, and there it is. So watch, if I would take this thing just as a little check, you don't have to do this, but if you were going to take this, multiply it by this right here, you should get this number right here if that division is correct. Alright, here's another one. Kind of looks the same, doesn't it? It looks like it's, it's written as a fraction now, so we don't have to worry about messing around with that. But we're going to do it in what's the word? I keep saying scientific notation. In synthetic division is what I want to say. It's a little bit different though, so watch. It's 2p minus 3, and then inside of here is 4p to the fourth. Now watch carefully. There's a gap in here, isn't there? We talked a little bit about that in the last problem, but we need to fill it in. We got a p to the fourth, and then it jumps to a p squared. We need a p to the third, a p cubed right here. We won't explain why right now. We did it when we first taught the lesson. But I need to put a 0p cubed right there. Then minus 17p squared plus 14p minus 3. Again, I need this coefficient to be a 1, so I'm going to divide everything by 2. So a lot of this is very similar to what we did earlier. A little bit of twist with that 0p cubed that we hadn't had before. Let's see what we get now. We get p minus 3 halves. You may not have to do all this right here, but that's going to be a 2p to the fourth, and that's just a 0p cubed. This is a minus 17 halves p squared. This is a 2 goes into 14, 7p, and then minus 3 halves. Now we're going to set this up for our synthetic division. Put that little box thing. I don't even know if that has a name. 3 halves goes inside of there. Put the coefficients out along this line. So it's 2, it's 0. Make sure that it goes in descending order. 4, 3, 2, 1, constant. So you need the 0 there. Negative 17 halves, 7, and then a negative 3 halves. Leave a little space underneath it there, put a line, and take the very first number and drop it down, and multiply together. 3 halves times 2. So again, if you're not sure about it, jot it down. 3 halves times 2, pretty easy. That's just a 3. So that goes underneath the next number. A lot of people forget where to put that. You put it in that next open available spot. Now what do you do with these columns? You add them up. 0 plus 3 is 3. Do the same routine again. 3 halves times 3. 3 halves times 3 over 1. Nothing cancels here. It's just 9 halves. And it's positive, so we put just 9 halves right here. Let's add those up. Negative 17 over 2 plus 9 over 2. So negative 17 minus 9, what's that? Negative 8 over 2. Negative 8 over 2 is the same as negative 4. Repeat the process. 3 halves times negative 4. 2 goes into 4 twice. That's going to give you a negative 6, and that goes right under the next number. Let's add them up. That's a 1. Multiply it together. Oh, that's easy multiplication. 3 halves. Wow, this was nice. See how nice I was to you? These just add up to 0, so my remainder is 0. So again, what is it? My remainder is 0. This is my constant. In this case, we're using letter p. That's the p term. This is p squared. This is p cubed. So we've got 2p cubed plus 3p squared. I'm looking right here. This is where I'm looking. 2p cubed, 3p squared minus 4p plus 1. That's my constant, and then there's no remainder. And there's the answer to that division problem right there. Again, if you wanted to, you could take this, multiply it by whatever you're dividing by, and then you should come up with that top number right there if you wanted to. You don't have to. Let's move on. Alright, now these problems are a little bit different. Let's see, these functional notation kind of stuff, functions. So look at number 12. We're finding the f of negative 2 for this function right here. Basically, this is just a glorified plug and chug problem. Take this and just plug it in, and it's just substitution. Alright, so anytime you see an x, you're just going to stick in a negative 2. So let's do that. So it's just negative 2 times x cubed. Now remember, this is our x. It's kind of like f of x, f of negative 2. So every time we see an x, we're going to put in a negative 2. Alright, so it's negative 2 cubed plus 5 times x, which is negative 2, and then just plus 3. Now it's just a matter of simplifying this. You do this first, negative 2 cubed, which is negative 8. We'll write out this step. And this right here is minus 10, and then a plus 3. Let's do the multiplication first. That's a 16 minus 10 plus 3. 16 minus 10 is 6 plus 3 is 9. There you go. Just one simple answer for number 12. These next two are kind of the same deal. This tells you which function. You have two functions, p and r. You're putting this into the r function. So you come over here to the r. Wherever there's an x, only one place, you're going to replace it with a 2a. So watch. R of 2a is going to be just 3 times 2a plus 1. This is 6a plus 1. You can't simplify it, and you're finished. Next one's a little bit trickier. All you're doing is that negative 4, all that's doing is just multiplying by whatever p of a is. You go to the p function. Now you're replacing the x with an a, so it's just 4a squared minus 3. You simplify it, negative 16a squared plus 12. That's what your answer looks like. That's all there is to it.